Welcome to Next Gen Manufacturing. In a world filled with high-tech robotics and these massive complex CNC machines, it's kind of easy to forget about the basics. But today, we're diving into one of the most critical, most foundational tools in any modern workshop, the thread tab. This little guy, it's the secret behind pretty much every connection that holds our world together. So, have you ever really thought about it? How do you get those perfect, clean screw threads inside a solid block of metal? I mean, it sounds simple, but it's a real challenge of incredible precision that every single engineer and machinist has to master. Because if you get it wrong, well, you've just made a very, very expensive piece of scrap metal.
So in this explainer, we're going to build what I like to call a pyramid of mastery. We'll start at the bottom with the essential tool itself. Then we'll look at all the different types for every task out there. We'll figure out how to make the right choice, dig into the science of what these things are actually made of, and finally get to the techniques for nailing perfect threads every single time.
All right, let's jump right in. When you need to create threads on the inside of a hole, the thread tap is your absolute go-to tool. And yeah, the sheer variety of them can seem a little overwhelming at first, but trust me, understanding them is completely non-negotiable for anyone who needs to join parts with real precision and strength. This is the bedrock, the foundation of it all. Okay, think of it like this. You wouldn't use the same key to try and open every single lock, would you? Of course not. Well, the exact same idea applies to tabs. There is a specialized tool for every single job, and we're about to meet the 5 most common types you're going to run into. So let's meet the lineup. First up, we've got the taper tab. You see that gradual slope, that taper along the end? That's its superpower. That design makes it super easy to start a brand new thread in a hole. It basically guides itself in, making sure the thread begins perfectly straight and true. This is almost always your starting point. Now, let's build on that. Next in line is the plug tab. It has a much shorter taper, which means it starts cutting the full thread a lot faster. This thing is the absolute workhorse for what we call through holes. Holes that go all the way through the material. It's all about speed and efficiency. Okay, this next one, this is a specialist. It has a very specific mission. This is the bottoming tab. Notice how it has basically no taper at all? It's flat. Its whole job is to cut threads right to the very bottom of a blind hole. That's a hole that doesn't go all the way through. So you'd usually start the hole with a taper or a plug tap, and then you bring this guy in to finish the job and get those last few threads perfect. Now we're getting into solving one of the biggest headaches in threading, getting rid of the metal shavings. The spiral flute tap has these grooves, or flutes, that kind of look like a drill bit. As it cuts, it literally pulls those metal shavings, we call them chips, up and out of the hole. This is an absolute game changer for softer materials like aluminum, where those chips can really clog things up. And on the flip side, we have this spiral point tap. Instead of pulling chips out, its special angled tip actively pushes the chips forward ahead of the tap. Now, why would you want to do that? Well, it's incredibly effective for through holes in harder materials because it keeps the cutting area totally clear and prevents the tool from jamming up. Pretty smart, right? Okay, so we've met the team, we know what they are. Now for the really important part. How do you pick the right one for your specific job? This isn't guesswork, folks. It's a strategic decision, and it's all based on a few key factors. It really just boils down to a few critical questions you have to ask yourself. What material are you cutting into? Is it tough steel or soft aluminum? What's the thread pitch, the distance between the threads? Is it a coarse thread or a fine one? And of course, you got to match the tap size to the hole you drilled. Every one of these answers points you toward the perfect tool for that job. And here's why this matters so much. This isn't just some academic exercise. In a modern manufacturing shop, making the wrong choice means, best case scenario, you snap a tap. Worst case, you scrap an incredibly expensive and complex part that you've already put hours of machine time into. A little precision up front prevents huge costs down the line. All right, now we get to the really cool science behind next-gen manufacturing. It's not just about the shape of the tap. What it's made of is just as critical. The material science here is everything when it comes to performance, how long the tool lasts, and whether you get a perfect, clean cut. Let's break this down. Your basic, affordable all-rounder is high-speed steel, or HSS. But if you need to work with tougher metals, you'll step up to Cobalt for better heat and wear resistance. Now, for the most demanding, high-volume production jobs, you're looking at Carbide. It's incredibly durable, but it's also the most expensive. And then you get into advanced stuff, like tin coatings that add extra hardness, or powdered metals which give you this great balance of performance and long life. And that quote really just nails it, doesn't it? This isn't just about getting one job done. It's about investing in tools that are going to give you consistent, high-quality results for their entire lifespan. The right material science absolutely pays for itself in performance and longevity. We've made it to the top of our pyramid. You've picked the right type of tap, you've got the right material for the job. Now all that's left is the execution. Let's walk through the essential techniques to make sure every single thread you cut is absolutely perfect. Following these 5 steps is absolutely crucial. First, you've got to use the correct drill size. A tap drill chart is your best friend, seriously. Second, always use cutting fluid. It cuts down on friction and heat. Third, keep that tap perfectly straight as it goes in. Fourth, use the right speed for whatever material you're cutting. And finally, every turn or so, back the tap off a little. That little move is what breaks the metal chips and stops them from jamming up the tool. And hey, here's a super simple but vital pro tip for you. After all that work, don't just throw the tool back in the drawer. Take a second to clean off the chips and the cutting fluid. This simple little habit prevents rust and corrosion and makes sure your high-quality tool is ready to go for the next high-precision job. And when you look at it like this, you really see the evolution, right? We've gone from just basic steel tools and a lot of guesswork to a whole world of advanced alloys, data-driven decisions, and a demand for micron-level precision. What used to be considered good enough just doesn't cut it anymore in next-gen manufacturing. So what's the big takeaway here? It's that even in this age of crazy automation, mastering these fundamental tools and the principles behind them, that is the absolute key. True precision in modern industry is built on this exact foundation of knowledge and skill. It's non-negotiable. Which kind of leaves us with a fascinating question to think about for the future. You know, with 3D printing and additive manufacturing getting better and better, creating parts layer by layer, will this fundamental subtractive skill of cutting a perfect thread still be just as critical in, say, 20 years? It's definitely something to chew on. Thanks for watching.